Okay, welcome back to the Dublin Academy of Maths. Right, you can get me at dublinacademy@gmail.com. Okay, I'm Michael and I'm looking at Leaving Cert Ordinary Level Maths, Series 10, Episode 1, Paper 2, and it's Trigonometry. Okay, now I like well, not many people like trigonometry, but trigonometry is a kind of a puzzle to me. Okay, so irrespective of what I think, you might find it tough. Okay, so anyway, we're dealing with right angled triangles. Okay, right angle triangles, right? And these are the rules here. These rules are not in your tables. Okay, now I have a mnemonic for this, and it's silly old Harry caught a herring trawling off America. That's my mnemonic. Now, and this is a right angle triangle. These only work with right angle triangles. So when you see a right angle like that, this line here that goes like that, you know you're dealing with right angle triangles. And you go and you write out these formulae here. Now, this is the angle A. If I'm looking for the angle A, the line opposite the angle A is called the opposite. Okay, and the line adjacent to it is called adjacent, obviously. Okay, and the line opposite the right angle is the hypotenuse. Okay, now if I change that A to up here to A, everything changes except the hypotenuse. This now becomes the opposite. Okay, this becomes the opposite. So you have to change things around to suit yourself, okay, to suit the question. So remember that everything is flexible, it doesn't stay still. Okay, now there's another one also, and that's the I'll just do this quickly, Pythagoras theorem. Okay, now you've often heard of Pythagoras theorem. Now the normal one is this. Okay, they're always in this, and then they have, well, they're not on, but this gives you a whole number. Okay, so it said that x squared is equal to the sum of the two squares, 3 squared plus 4 squared. X being crossed the square root is the square root of 9 plus 16, which is equal to 5, plus or minus 5. But we're only interested in plus because we're dealing with lengths. Okay, so it's 5. So this is 5. But so say if I didn't have the 3, okay, and I wanted to find out well, say this is A, the opposite is, okay? Well, we change it because we were using that last time. We'll say this is A up here. And we'll say I'm looking for the adjacent. Okay, so the line adjacent to it. So I know that this hypotenuse squared is equal to the sum of the opposite two sides squared. Okay, now I manipulate the formula. 25 is equal to x squared plus 4, 16. Bring across the 16, x squared is equal to 25 minus 16. I just moved the same thing in here, I just brought the 16 over, became minus. Now this is algebra and it's series 1, and I'm not going to do any more with it. So 25 minus 16 is 9, square root of 9 is equal to 3. Okay, brought the square across, becomes opposite function, becomes the square root of 9, becomes 3. Okay, so the answer there is 3. So you can see that you can change things around, you can change things around to suit yourself, but as long as you remain within the logic of maths. Now, I'm going to do, so that's Pythagoras theorem explained, and now I'm going to show you a question, right? So I have we'll use the same one here, okay? So we take out the lines, and we put in our values. So we've got, we're looking for B, and there's A, and we're given all the lines, but we're not told. Right, okay, so I have to find A and B, right? So the angles A and B. Now this should be fairly self-explanatory, so I can use really anything because I have all the sides. Okay, so it's up to you to choose. Now if I want to find this angle A, I can go, well, I can pick tan of A, opposite over adjacent. Okay, so I'm going to pick tan of A. Now, normally I wouldn't have so much variety here. Normally there'd be one missing, and then I'd have to use the hypotenuse or the adjacent. For example, if 3 wasn't there, I'd have to use the cos. You get me? But now that I have everything here, well, let's take out let's take out the 3 and let's make it cos. Say it's 3 is not there, we don't know. Okay, so we have the adjacent line to it, and we have the hypotenuse, always the line opposite the right angle. So adjacent and hypotenuse, adjacent and hypotenuse is the one that only works. Okay, so you have to write them out and then figure them out. So cos of the angle A is equal to adjacent, which is 4 over 5. So 4 over 5, cos of A is equal to 4 over 4 divided by 5. I use my calculator. Okay, 4 divided by 5 is equal 4 divided by 5 is equal to 0.8. Now the angle cos A is equal to 0.8. If I want to find that angle, I have to do the second function and get the cos, the inverse cos. So I press inverse function and I press cos, and this will be its inverse function, and then I press 0.8 and I should get an angle. Okay, so I go inverse, and we're doing cos, inverse, and you see I've got cos here. You can zoom, maybe you can see it, but you get the idea. Inverse cos 0.8, and it's equal to 36 degrees and 0.86. Okay, so it's 36.86 degrees. So that's cos A is equal to that. Okay, so cos of 0.8 is equal to 38. Now, 36.86, how do I find how many, that's how many degrees, but how many minutes is it? Well, I can take away 36, and I'm left with 0.86, and I multiply that by 60, and that will give me in the degrees. So minus 36 equals 0.869, okay, and I multiply that by 60 to change it into minutes, and it's 52 minutes. So that angle there is 52 minutes, so it's 36 degrees, 52 minutes. 52 minutes. Okay, now you see that now. I'll do another one now to prove. Now I can go ahead now and I can prove that that angle is. Now I can find this line here, and I know that x squared is equal to the sum of the squares minus the adjacent. Okay, and that's the same as for 25 minus 16, which is equal to the square root of 9, which is equal to 3, as we said the last time. So I can work it out my other side by putting in the values for the Pythagoras theorem. Now I can find out what B is equal to. Well, we can add them all up later and find out what B is. B is equal to, well, there's two ways here. All angles in a triangle add or sum to 180 degrees. Now I can add 36 degrees and 52 minutes to 90 degrees here, add them, and then take away 126 degrees 52, that looks right, and then take away that from 180. You follow what I'm getting at here? 126 minus 52, that's 8 minutes. Okay, I borrowed 1 and I change it back, 73286 3. I should take this slowly. Okay, so it was 180 equals, and it should be 53, minus 36, that should be, no, 100, that should be 36, 126, and that's right. Okay, 53.8. Okay, so it's 53 degrees and 8 minutes. That's one way of doing it, okay? Now we can also, add the same again, I get B, and I just go, well, I have everything here, so I can pick anything I want. I'll go for tan, so tan of B is equal to opposite, which is 4, the opposite line over here, which was adjacent to A, all over, opposite over adjacent, which is 3, a line adjacent to this. So it's tan of B is equal to 0.75, no, that's not 0.75, that's 1.25, so 4 divided by 3 is 1.33. Okay, now to get the inverse of that, I press the function inverse on my calculator, and I press 1.33. No, sorry, I press tan. The inverse tan comes up because I pressed the inverse, and then I press 1.33. Okay. So inverse tan, I'm going to put it out here, inverse, which I've done, inverse tan, and it's 1.33, and it's 53 degrees, and 53 degrees and something minutes. So inverse tan again, 1.33, 53 degrees and 8 minutes. Okay. Right. Right, great. So that's all. They should all add up 53 to there's something wrong here. A tan of 4.5. I'll do this again. Inverse 1.3. Inverse tan 1.333 equals 53 degrees. 0.12. Okay, so 53. They should add up to 180. Doesn't look like they do. Oh, they do. Yeah, 53. Right. And so now that's that out of the way. Let's go on and have a look at another part of the question. So you get that. So now you know how to find angles given formulas. These are for right angle triangles, and you know how to inverse it now, and given the ratio you can find the angle. Okay, so this is a right angle triangle, and it's right, so it's got 15 here, and it's got X here, and it's got 42 here, and it's got B here. Okay, so now which one do I use? Well, I'm looking for B. I've got I don't know this one here, and I'm asked to find the length of the lines. Okay, so I'm okay, right. So I've got hardly any lines here, but I've got an angle. Okay, so I've got an angle and I've got the hypotenuse. Okay, now I can use either this one or this one. Okay, so I'm going to use sine of 42 degrees. Okay, so sine of 42, because I'm picking the angle now, 42 degrees, because that's what it is here, is equal to opposite, which is x over the hypotenuse. Okay, sine of 42 is the opposite over the hypotenuse. I can't use the adjacent because I don't have the adjacent, so I have to only use this one. This is the only one I can use. So I manipulate this formula, and when I get 15 times sine of 42 degrees is equal to x, so I get sine of 42 degrees, I got sine 42, 0.16, 15 times 0.669, and then I multiply that by 15, and the answer is equal to 10 to nearest decimal, 10.03, so it's 10 centimeters, if that is in centimeters. Okay, so that's how you work it out. So that's 10 centimeters, and I can go along and I can find the other side. How do I find the other side? I can find the other side by the square of the hypotenuse. 15 squared is equal to 10 squared plus x squared. X squared is equal to 15 squared minus 10 squared. X is equal to the square root of 15 squared, which is 225 minus 100. X is equal to the square root of 125, and right, that doesn't work out, so the square root of 125 equals 11 point something, 11.18, so that changes that to 2, so it's 11 centimeters to the nearest centimeter. 11 centimeters. Okay, so Pythagoras and using your terms here are involved. Now let's have a look at the questions. The questions are just 3 questions here now. I'm going easy on you today. Let's get back up there. And so here we are. Find the lengths of the sides marked with the letter Y. Okay, this is upside down, right angle. Okay, you can change it around and suit yourself, but make sure you hold on to just turn it around if you want to get a better idea. Now this is more complicated. Okay, you have to find the length from there to there. Okay, given these lengths, right? Good luck with this one. This is quite interesting to do. There's no angles given on this question. I don't see any angles. No, there's no angles given on this question. Questions. No. That's 7 centimeters by the way, and this is 11 centimeters. Okay, now you should do these questions straight after this, or in the next half an hour, to embed it into your brain, and best of luck. Bye bye.